class. Today we will be doing the 2006 AP Chemistry free response question number 3. So let's read part A. A compound contains the elements C, H, N, and O is analyzed. When a 1.2359 gram, so you have 1.2359 grams of this compound, is burned in excess oxygen, 2.241 grams of CO2 is formed. So you have 2.241 grams. The combustion analysis also shows that the sample contains 0.0648 grams of hydrogen. So then you have 0.0648 grams of H. So in part 1 of A, you need to determine the mass in grams of carbon in the 1.2359 gram sample of the compound. So what you can do to solve for this, you can use stoichiometry and use the grams that they gave you from the CO2 and find the grams of carbon. So part 1. You start with 2.241 grams of CO2 and you have 44.01 grams. That is your molar mass. So you have 1 mole. Now in 1 mole of CO2, you have 1 mole of carbon. And 1 mole of carbon is equal to 12.01 grams. So if you were to calculate this out, this equals 0.6116 grams of carbon. So now we will be doing part 2. So if you read the question, when the compound is analyzed for nitrogen content only, the mass percent of nitrogen is found to be 28.84%. Determine the mass in grams of nitrogen in the original 1.2359 gram sample of the compound. So we have 28.84% of nitrogen. So an easy way to do this problem is just to use a proportion. So we have X amount of grams over 1.2359 grams, so that is from your original sample, and that is equal to 28.84% out of 100%. So if you use the proportion and you multiply it out, you find that your X amount of grams is equal to 0.3564 grams of nitrogen. And now we will be doing part 3. So if you read the question, it says, determine the mass in grams of oxygen in the original 1.2359 gram sample of the compound. So if we need to find oxygen, we already know hydrogen, we already know the carbon, and we already know the nitrogen. So we can just subtract. So from the total, we can take 1.2359 minus 0.0648 plus 0.6116 plus 0.3564. So this is your hydrogen, carbon, and nitrogen added up, subtracted from the total amount. So if you do this, you get 0.2031 grams of oxygen.
Part 4 of the problem asks us to determine the empirical formula of the compound. It is helpful to remember our poem for this part of the problem. Percent to mass, mass to mole, divide by small, multiply till whole. In parts 1, 2, and 3 of the problem, we have the masses of hydrogen, carbon, nitrogen, and oxygen, which are already written out for you here. So now we will divide by their molar masses. 12.01 for carbon, 1.008 grams for hydrogen, 14 grams for nitrogen, and 16 grams for oxygen. This will give us the moles. 0.05092 moles for carbon, 0.06429 moles for hydrogen, 0.02544 moles for nitrogen, and 0.01269 moles for oxygen. Now we will divide by the smallest moles, which, as you can see, is oxygen. 0.01269, and again, the smallest number of moles. This gives us 4.013 for carbon, 5.066 for hydrogen, 2.005 for nitrogen, and 1 for oxygen. This works out nicely because we can round these numbers easily. So we have C4, H5, N2, and oxygen. For part B, it says a different compound which has the empirical formula CH2Br has a vapor density of 6 grams per liters at 375 Kelvin and 0.983 atm. Using these data, determine the following. So as you can see, you need to write out all of the information that is given so that you can use that in part 1 to find the molar mass of the compound. To find the molar mass, we are going to use the equation PMM is equal to DRT. So, and then you solve for molar mass. So the density is given as 6. R is 0.0821, and temperature is 375 Kelvin, divided by the pressure, 0.983. And this gives you the molar mass, which is 188 grams per mole. For B part 2, we need to find the molecular formula of the compound. Remember, to find the molecular formula, you need to do the molecular mass divided by the empirical mass. So the molecular mass is what we found here, 188, divided by the empirical mass, which you use this equation, or this formula, and that gives you 94. You divide that, and it gives you 2. So we have CH2Br, and we take this 2, and then we distribute it in. So that gives us C2H4Br2.